developed an application or are developing an application where you've had to implement login? So most people. I hope that even if you have some experience doing this, that this talk is going to be very useful for you and illuminating. So as mentioned, my name is Kim Maida. I am a Google developer expert, and I also draw custom stickers. And as a head of DevRel, it's part of my job to give stickers to people. So if you're interested in getting stickers, come see me after the talk. So I'm the head of developer relations at a company called Auth0. And Auth0 is what we call identity as a service. So essentially, it's a cloud platform that helps you to authenticate users and protect your data and APIs. So the purpose of Auth0 is really, and other products like it, is to deal with the complexity of authentication and authorization, essentially so that you don't have to, so you don't have to be so burdened by it. So we're going to take on authentication as a project in something that we're building. We can really start with something like this sort of vague idea of, I'm going to draw a couple of circles. I know I need to maybe go and Google authentication. And you can get to here, you can draw the rest of the owl, you can do the rest of the auth stuff in these 2 steps. It actually can be that easy if you do something like use a service that provides this for you. But you're here today to learn sort of more about this, right? So you don't need all of these interim steps to get to this beautiful end result. You can just draw the rest of the owl without needing all of these steps. But what I'm going to do for you today is hopefully illuminate some of these details in the middle to help you get to that full picture with a more robust understanding. So I'm going to start by giving you a little bit of an introduction to authentication for applications that run on the web. First of all, we have this thing called an authorization server. And this is really kind of just a fancy word for a set of endpoints whose purpose is to interact with the user and to issue tokens. So an authorization server is capable of issuing several types of tokens, including ID tokens, which identify the user for the purpose of authentication, and also access tokens, whose purpose is to authorize access to resources such as APIs. Now, we have different application architectures when we build all kinds of apps, including Angular apps. And I want to take a minute to sort of understand what the use of an authorization server looks like with these different architectures. And I'm going to start with cookies. Now, cookies are traditionally used to secure server-side web apps, applications that run on the back end. This is stuff like apps built with .NET, Java, PHP, so on and so forth. And what this typically looks like is you have your browser, and your user is looking at the browser. And then on the server, you've got a back-end web application, and maybe it gets data from a database. And then in our scenario, we also have this thing called the authorization server, the set of endpoints to issue tokens. Now, using the browser, when the user wants to log in, what we're going to do is we're going to send an authorization request to the authorization server. The authorization server then, in its turn, is going to take that request, and it's going to issue an ID token. It's going to deliver that ID token to the backend application. And the server is then going to set a cookie in the browser, which represents the user's session. At this point, the user can be considered authenticated. Now, whenever the user looking at the browser makes a request for pages and data to the server, whenever there's traffic to this domain, the cookie is going to be attached by the browser, and it's going to be sent to the server. If everything is good with that, then the requested page HTML, along with any sensitive data that can only be shown to authenticated users, can be delivered to the browser, and the user can look at it. Now, if the cookie is expired, or there is no cookie, and a request is made for protected data, then what's going to happen is the server is going to return a 302 redirect status. What this is going to do is it's going to tell the browser, hey, you need to do a full page redirect somewhere where the user can log back in, where they can re-authenticate. Once they've done that, then we can go ahead and send secure data to the browser once more. Now, when we build Angular applications, we are building single-page apps. So Traditionally, when we are building single-page apps, we use a method of authentication called token-based authentication. This works a little bit differently from cookie-based authentication. So we have our browser, and then when the user navigates to our application's location in the browser, the app is actually downloaded, compiled, and it runs inside the browser itself. Then we have our API that may or may not live on the same domain as our application. And then we've got this authorization server. So when the user wants to log in, as before, we're going to make an authorization request to that authorization server. Authorization server is going to verify the user's credentials, ensure that everything is well formed with the request, and then it's going to issue tokens. The tokens are delivered to the application in the browser. And then what the client can do in the browser is it can parse and validate the ID token. This is the one with information about the user. And at this point, we can consider the user authenticated because we know who they are. Now, when we go to make HTTP requests to an API, then we're going to attach the access token in the authorization header of that request. The API is going to accept that request in the access token. It's going to verify the access token using some kind of middleware. And if everything works out with that, then it's going to return data in the form of JSON traditionally to the application, and the application can consume it and display it to the user. Now, so we know a little bit about the basics of authentication strategies at this point, but how do nuances in application architecture drive the choice that we need to make for the strategy we want to do when we are tasked with implementing authentication? So there's a couple of common architectures when we're dealing with web applications that have a single-page application layer in them. And one is that maybe your single-page app and your API are actually on the same domain. So this would be the case if your app was at myapp.com and your API was at myapp.com/API. This is pretty common. For example, if you have an Angular app that's running on a .NET backend that also serves API endpoints, and everything is sort of exposing, the application is exposing its own API for the exclusive use of the presentation layer of the single-page app, then in that case, you should actually seriously consider securing everything with cookies. In this scenario, there's not really a reason to use access tokens. What this would look like in implementation is something a little bit like this. So on the backend, on the server, you have a backend that is capable of executing code. It's also providing API endpoints. The backend then serves the single-page application, which runs in the browser. And then you've got your authorization server, right? So what we can do is we can actually use backend routes to handle the login portion. And then the backend application does all of the interactions with the authorization server in order to authenticate users. Once we know who the user is in the backend, then the data that's moving between the backend and the single-page app can actually just be secured with an HTTP-only cookie that serves as a session cookie. Now, maybe you don't have a backend. Maybe you're in a serverless scenario. Maybe you have a static site that doesn't have a backend. Maybe you've got APIs on other domains. Or maybe you don't right now, but you know that you're going to need to scale in the future, and that's going to become a need. And if this is the case, if you have a single-page app and cross-origin APIs, then the solution for you is going to be to use tokens. Now, there are best practices I want to talk about for using tokens with single-page applications. And in order to address these, I kind of want to go just a little bit back in history and talk about when the OAuth 2 spec was adopted. So this happened in 2012. In 2012, single-page apps weren't really mainstream yet. So for example, AngularJS is one of the older JavaScript frameworks, but it didn't actually gain real traction in sort of the web development world until around 2014. So there were standards around how should we handle browser-based apps, but these apps weren't really mainstream yet. So historically, what we would do was deliver tokens to the browser, to the application running in the browser in the form of a browser redirect. So we would make a request to the authorization server, and then that same endpoint that receives the authorization request would return the tokens to the browser in a URL hash fragment. Now, there's some security risks that are inherent with doing something like this, with putting something like an access token especially into a browser URL. Now, there's a lot of ways that we work pretty hard to mitigate the risks of doing this. Risks like, sort of exposing the tokens in the browser history, which is, as we know, accessible to any JavaScript running on the page. So we work hard to take care of this, right? But at this point in time, modern JavaScript is really just eating the world of web applications. It's time to recommend new best practices. There's got to be something a little bit better than just putting them in the browser URL and then putting the onus of securing them on the implementers, on the developers. So in early 2019, some new best practices were drafted about this. Now, they're not actually super new because it's the same approach that's used in mobile applications because mobile apps are also public clients, similarly to how JavaScript apps running in the browser are public. And it looks like this. We're going to exchange a code for a token in this. So the first thing that the application has to do is create a random string. This string is called a code verifier. Then we're going to use a hashing method called a code challenge method to compute another string called a code challenge from the verifier. Then when the user comes along, we're going to make an authorization request to the authorization server. We're going to send the code challenge and the code challenge method to the authorization server's authorization endpoint. The authorization server, in its turn, is going to generate a code, and it's going to send the code to the browser, and the browser's going to receive it in a query string. Now, we can do this because interception of the code by itself is actually not dangerous. Alone, it doesn't grant access to anything. If a malicious actor got a hold of the code, they couldn't really do anything with it because there's more to this. So once we have the code, then the code and the code verifier is sent to the authorization's token endpoint. This is a different endpoint than the authorization endpoint. And the authorization server is then going to calculate the code challenge from the verifier using the code challenge method that we set in the first pass, right? So it sort of had this information already. It's then going to compare the code challenge that the authorization server calculated with the challenge that was sent by the application earlier. And if the challenges match, then tokens are issued and they're delivered in a JSON object to the application, which the authorization endpoint was not capable of doing. So if we come back to all of the risks of having tokens exposed in the URL and the mitigations work we had to do to make this okay, we don't really need that anymore. It's no longer necessary. But this was like a ton of work, right? Who wants to do this, especially if what we had was already working and it was pretty easy? Well, the nice thing is SDKs can do this work for you. So if you use an authorization server, a service that sort of provides this authorization server, they're also going to be beholden to the community to provide resources and stay up to date. So they can provide SDKs that basically you can just plug and play and upgrade your authentication flows in your applications relatively painlessly. So the new best practices for this, what do they mean for you as a developer? Well, if you are developing a new application, if you've got a greenfield, you're starting off from scratch right now, then I would strongly encourage you to look at the new approach. It is more secure, it requires fewer mitigations, it's just going to be the better option at this point in time. However, if you already have existing applications, maybe they're pretty far along, your Auth solution is pretty much set up, or they're already running in production, I want to emphasize that there's no new threats to this old approach. It was just that basically the people who steward the standards, it's their responsibility to make sure they're always promoting the best possible, most secure approach. We work on teams, we have products, we have deadlines, we have clients. We have to take a pragmatic approach. So I would encourage you to assess your needs and then make the choice that makes the most sense for your team, your application, and your company. If you're already mitigating the risks, then there's no new risks. There's not some big, huge security issue or vulnerability that all of a sudden makes this less secure than it has been for the last 8 years that it's been recommended. So let's assume for the next sort of half of the talk that you are using token-based authentication. And I want to sort of shift gears and talk about how Angular as a platform helps with authentication. We can do this by creating sort of a to-do list. And I don't mean I'm going to stand up here and sort of live code a to-do list. These are just things that we need to be able to handle when we're doing auth with Angular. So we want to be able to elegantly manage authentication events. This might be stuff like token availability. It might be user login status. This changes depending on their actions. We also are going to want to send the token with API requests. And we need to be able to restrict access to certain routes in our application to provide a good user experience when the user is looking at the app and tries to go somewhere they're not supposed to go. So the first thing was managing authentication events. And luckily for us, we have this awesome library packaged with Angular, which is, of course, RxJS. Now, RxJS can help us do a lot of different things. And one of the very useful things it can do is enable us to interact with the SDKs reactively. Now, a lot of SDKs that are provided for JavaScript in general aren't built reactively. So they use callbacks, they use promises, they use async await. This is not really usually what we do in Angular when we're using RxJS. But the nice thing is, RxJS enables us to convert those different types of asynchronicity, I have no idea if I said that right, from external libraries and turn them into observable streams that we can more easily consume and interact with. So maybe we're using an authentication SDK, and it provides a callback method to return token data from the authorization server. So what we can do is we can use a method like bind callback or bind node callback, depending on the type of SDK, from RxJS, and we can create an observable that's going to emit when the callback completes. When we subscribe, we can also pass options to the bound SDK method if we need to. And then also, if the library returns promises, then we can do something like use the observable creation method to convert a promise to observable and then also subscribe to it in sort of a similar fashion. Now, in addition to being able to interact more interactively with SDKs and libraries, we can create our own streams of authentication data for our application's use. This could be things like token availability, user info, login status, so on and so forth. So for example, maybe we need to create a stream for user data. We can create a private behavior subject in an authentication service. And then when data becomes available, or it changes as some result of an authentication event, then we can tell the stream to emit values with the updated data. And then we can expose a user observable publicly to our application so that we can consume it elsewhere in the application, subscribe to it, and take any action that we need to when the data changes. Now, these are just a couple of pretty high-level examples of how our RxJS can help us to manage authentication data and things like callbacks. And I'm sure you can find more ways to leverage the power of RxJS in your applications when you're dealing with authentication. And if you come up with other ways or you've already done this, I would love to hear about it. This is something I'm very interested in personally. So if we come back to our to-do list, we've learned that we can elegantly manage authentication events with RxJS. This brings us to setting the token with API requests. Now, we do this with HTTP interceptors. And these are services that transform our requests or responses. So when we call our API, what we can do is we can intercept requests using an interceptor service, and then we can attach the token in the authorization header of this outgoing request, and then send that request on its way to the API. So if we look at our app routing module, our module has a providers array. And in order to enable this, we want to provide the HTTP interceptors token from Angular Common. Then we're going to tell it what class we want to use, an interceptor service. And then we're going to set multi to true because we can potentially define multiple interceptors. They'll just be called in the order that they're provided here. So inside our interceptor service, we're going to do some necessary setup. There's going to be an intercept function. And then inside that function, we might have something that looks like this. So what we're doing here is we're cloning the HTTP request that's coming in. We're setting the authorization header with the value of the token. And then we're sending the cloned request on its way with the new header. Now, currently as it stands, there's not a way in sort of the Angular configuration to only run interceptors on specific requests. But we can very easily do this with just good old-fashioned conditional logic. So let's say we want to clone and modify requests based on some condition. And this is a good example because we need to be cognizant of where we're sending our token, right? If we need to make sure that we're only sending the token to the API that we want the token to be shared with. If we're calling multiple APIs, we don't want to send the token with every single request because some APIs might not actually belong to us, or they might not need the token, and therefore we're just freely sharing it when we really shouldn't. So we can verify that the requested endpoint is our API's domain, and then we can clone it if necessary, if it meets the condition. And if not, we'll just send the original request that doesn't have the token attached to it. We can also implement asynchronous interceptors. Now, this is particularly useful for if we have a situation, for example, where after an authentication event, we're redirected back to a page and a bunch of requests are supposed to be made that should only be successful if you're authenticated. Now, what we don't want to do is sort of send a bunch of requests while somebody is still in the process of having their authentication recognized by the application and send it too early. So we can use RxJS to wait until data becomes available before we do something like clone the request and attach the header. So let's say that we have a token stream in our authentication service, and we just want to ensure that the token is present in the app before we start sending something like a header of authorization undefined. So we're going to set the token once it's available, and we can do something like use the merge map operator to ensure that if there are multiple requests, none are going to be canceled by a new request. So if we come back to our list now, we can use interceptors to send the token with our API requests. And this brings us to the last item, which is restricting access to certain routes. Now, we're probably all relatively familiar with route guards. Route guards implement 3 different interfaces. The most common sort of default one is canActivate, and this prevents unauthorized users from navigating visually in the UI to a route. But the important thing to know about this one is that the code is still loaded. So we're still getting the code for that route in the browser, even if the user doesn't have access to it. canActivate child works very similarly. It prevents unauthorized users from navigating to all children of a specific parent. And then finally, we have canLoad, which prevents lazy loaded modules from downloading to the browser in the first place if the user is unauthorized to view them. So if we come to our app routing module, we're going to do our sort of necessary setup. And we're going to protect the profile route because a profile is pretty useless to someone who's not logged in and they don't have a profile, so we don't want them to be trying to look at it. We can use the interface name as a property, and then if we want to pass multiple guards, we can do so because we're going to be able to pass an array here, and the guards will just run in the order that they're provided in the array. Now, a single guard file can implement multiple interfaces. So you can have a canActivate and a canLoad in the same auth guard file. Now, in this case, we're talking about canActivate. So we're going to have a canActivate function. That function is going to return an observable, a promise, or a Boolean. And inside that canActivate function, maybe we have something like this. We're going to deny access based on some condition we define. Maybe our authentication service provides a getter that says, just returns a Boolean saying, is the user logged in or not? Now, we're going to return false if this is the case. And then we can also take some action here. So we could redirect the user to a login page or open a modal that says, hey, here's your login prompt. And then if they should be granted access, then we're going to return true and navigation is allowed to proceed. Now, the other thing we can do is guarded lazy loading. So we would use a canLoad route guard to do this, to asynchronously load sections of our application only for the authorized users. Now, it still holds true that the front-end code is not a good place for any kind of really sensitive data. So you wouldn't want to put sensitive data behind this and then expect it to be completely secure. But with guarded lazy loading, we do get a couple benefits. One of them is really smaller bundle sizes and some added protection. So in our app routing module, when we're setting up our routes, we're going to lazy load a routed module, and we're going to add a canLoad route guard. In this case, I'm using an example of a role guard. So we're going to check if the user that's trying to access has a specific user role. And we can provide some route level data. In here, I'm saying the expected role for this person to load this admin module is I want them to be an admin. And we can do this with other route guard types or for any sort of route-specific data. It's not exclusive to CanLoad. So in our role guard, we have our CanLoad function. Again, this is also going to return an observable, a promise, or a Boolean. And then inside our CanLoad function, maybe we have something that looks more like this. So we can return an isAuthenticated observable from our authentication service. And this observable, maybe it emits true when the user is logged in, and then it emits false when they're not. So we can use the tap operator to execute a side effect. We can say, if the user is not logged in, then we have access to this segments thing in the URL. This is a URL tree. And what this does is it enables us to actually get to the path of the guarded route, even though the code is not actually existing in the application right now. And then once we know that path, then maybe we can do something like prompt a login, be able to pass in the redirect path so that after the user logs in, we can just send them to the place they were trying to go, and then we don't interrupt the flow and dump them back on the home page or something annoying like that. Or if the user is logged in, then we have to make sure they have the expected role, that they're an admin. And if they don't, we can do something like send them to an unauthorized page. So we've now sort of covered all of our items. We've learned that we can use route guards and lazy loading to restrict access to certain routes in our application. So now our list is complete. So as a really quick recap, we covered some authentication basics. We also talked a little bit about architecture considerations and best practices for the different architectures, as well as strategies to help you handle authentication with the Angular platform itself. So at this point, I hope that you just have a sort of a better idea of how to get from those two circles to drawing the rest of the owl. And these slides are available here. If you have any questions or comments, of course, I'm here, but also I'm very active on Twitter, so you can hit me up there. And I really appreciate your time today. Thank you very much.